In this video, we are going to look at probability distributions, and we want to go through a summary of probability distribution 1 under random variables, and basically want to look at discrete random variables. And we shall say that in this chapter you shall be able to look at probability distributions for discrete random variable, how to calculate expectation of x, that is the mean, how to calculate and use the variance of a random variable x, about the cumulative distribution function capital F of x, and how to obtain, how to talk about the results relating to expectation and algebra for variables x and y. And we know that when a variable is discrete, when we talk of a discrete random variable, or when a variable is discrete, then it is possible to specify or describe all its possible numerical values. You can easily count a discrete random variable. Its values can easily be counted, and we have examples like if you have a group of 4 students. In these students, we can either have no female, or we can have, that means if there are 4 students, if we have 0 no female, then it means all of them are males. If we have 1 female, then 3 are males. If you have 2 females, then 2 are males. If you have 3 females, then 1 is the male. If you have 4 females, then no male. So the number of females can take on these values, and that means you can count that these are the number of females. If you throw a die, as you know that a die has got 6 faces, then it is possible to get a 6 appearing on top a number of times, and can appear once, or it can appear 2 times, it can appear 3 times, it can appear 4 times, it can appear 5 times, it can appear 6 times, it can appear 7 times, it can appear 8 times, up to infinity, meaning that you can count continuously and you don't have fractions, because the number, you can get a number of 6 appearing on top in a discrete manner, or they are countable. We can even have the number of boys in a group. There are 10 students, and in this group they can say, go and check how many boys are there. You can find that this student, there is no boy, all of them are girls. Or you can find there is only 1 boy, 2 boys, 3 boys, 4 boys, 5 boys, 6 boys, 7 boys, 8 boys, 9 boys, or all of them are boys and there are no girls. So you can easily count. Therefore, this group, we say the variable refers to number of boys and they are discrete. You can count. Now, all countable variables are said to be discrete, or they form a discrete domain. A discrete domain. Now, when it comes to our probability distribution, we can say that a probability distribution gives the probability of each possible variable. If you have a variable, then it is possible to have to give it a probability of that variable appearing. Like how many times, what is the probability that you can have 6 boys out of 10 students? So a probability distribution is that one which gives the probability of each possible value of the variable. And you want to use an example that maybe you have got fuses, some are faulty, others are not faulty, and by mistake, 3 faulty fuses are put into a box of 2 good ones. The faulty and good fuses become mixed up and you cannot separate them by mere looking at them. So they are indistinguishable by sight. And now, if you are given a task that choose 2 fuses, or if 2 fuses are taken from the box at random, what is the probability that you take no faulty, 1 faulty, or 2 faulty fuses? A question like this, it is possible to show the outcomes and the probabilities on a tree diagram, and we can use the variables f standing for faulty fuses, then f complement standing for not faulty, or these are good fuses. And we have our box. Now it contains 3 faulty, that is 3 faulty fuses, and 2 good ones. 2 good ones. Meaning that the total number of fuses in total are 5, which are indistinguishable. And if we develop our tree, and if we are to choose 2, if 2 fuses are taken from the box, want only 2, that means you can choose a faulty or the one which is not faulty. It is possible that you can choose a faulty, and the probability of choosing a faulty, as we said, it is the number of faulty over the sample space, which is 5. Meaning that those which are not faulty, they are 2 out of 5. And this is the first time you pick, and those are 2 possibilities. The second time to pick from the box, and here the picking is without replacement because we want 2. So I've taken 1, that means it is without replacement. You don't replace it, you want 2. And if we are to pick the second one may be faulty or maybe okay, that is the second one. Here the second one may be faulty or good. Now, if we pick the first one was faulty, it means the number of faulty ones will reduce to 2, and now I want to pick, and possibly the one we picked is faulty. It means we are picking up from 2 to be 2, but the number will have reduced to 4, because at this level they are total 4 because the one has been removed. Meaning that 2 over 4 plus 2 over 4 gives you 1 automatic. The first one is good, followed by a faulty one. Meaning that if you have removed the good one, there is only 1 left, and 3 faulty are still there, but over 4. But this becomes 1 out of 4 because there is only 1 good one remaining. So this can be our simple tree for the 2 faulty fuses to pick from our bag, from our box. And our question says that if 2 fuses are taken from the box at random, what is the probability that you take no faulty fuses? probability of no fault. No fault, it means both of them are good. So it is the probability of F1 and F2, but all of them are good. We have picked at random and we found out that all of them are good, and from the tree, as you can see, the first one to be good, the chance is 2 out of 5. 2 out of 5 times the second one to be good, which will be a quarter, as you can see, a quarter, and when you multiply it becomes 0.1, or 2 out of 20, which is 1 over 10, giving us 0.1. So part B, 1 fault fuse. 1 fault fuse, this one qualifies, whereby you have the first one is faulty, the second one is not faulty. This one qualifies. Then 1 faulty fuse, the first one is not faulty, it is good, followed by a faulty one, and probability of 1 faulty. 1 faulty, it means we shall have to follow this one, and it will be 2 over 5. The first one is not faulty, it is good, times the second one, which is faulty, and 3 quarters. As you can see, 3 quarters, or so it is 2 over 5 times 3 quarters, or the first one is faulty, which will be 3 out of 5 times the second one, which is okay, which is 2 quarters. 2 quarters, and this one by computation will get this should be 0.3 plus 0.3, which should be 0.6. That is the probability of having only 1 faulty fuse. Now we have part C, that probability of picking 2 faulty fuses, probability that all of them, 2 of them are faulty. It is very clear that if all of them are faulty, you get 3 out of 5 and 2 out of 4, because the first and the second one are all faulty, and automatically this will give you 0.3 as the probability of having all of them faulty. So this is the solution to our question. Now, as we said, that probability distribution gives the probability of each possible value. The probability of each possible value is given, and we want to look at our question, which says that the faulty 2 fuses are taken from the box, and we are talking of faulty fuses, and therefore the value being considered in our solution is faulty fuses. So we are going to define our variable as we had said, f defining for faulty fuses, and we use capital letters when we are defining variables, and can be denoted by x. So we can say let f be denoted by x, because x would be our variable that will connect our solution, and therefore it means that the values that x can take are, so x can take on values, as you can see from the tree, that if we are looking at faulty fuses, x can take on 0 because all of them can be good. This is good, the second one is good, and it is no faulty one, meaning that it can take on 0. It is possible that we can pick fuses and all of them are good. Therefore, x can take on 0. Like at this level, number of faulty ones are 0 because we don't have faulty fuse here. Or we can have x taking on 1 because it can be one faulty, as you can see, one faulty, the second one is okay, one faulty, the second one is okay, and it can take on 1. Or 2, we can have 2 fuses from the box, all of them faulty. So it means these are countable. We can have no faulty fuse, we can have one faulty fuse, or all of them can be faulty. Therefore, probability that x takes on 0, therefore the probability the random variable x takes the value 0 can be written as probability of x can be 0. We can have no faulty fuse, and in our calculation, probability of having no faulty fuse is automatically 0.1. So that probability is 0.1. Probability of x taking on 1, whereby we only have one faulty fuse, that one is 0.6. as you can see that in our computation we got 0.6. Probability that x can take on, or all of them are faulty, is 0.3. as you can see what we have calculated, having all of them faulty, 0.3. and the probability that there are no faulty fuses, that is the probability that the variable x takes on value 0 can be written as px equal to 0, which is 0.1, and probability of x equal to 1, 0.6, probability of x equal to 2, 0.3. Similarly, probability of x equal to 1 and the probability of x equal to 2, as we have seen, they are indicated here. Sometimes these are written in form of a table, and you can have x, then probability of x, and in the summary form you can have 0, can have 1, you can have 2. So x equal to 0 is 0.1, probability of x equal to 1, 0.6, probability of x equal to 2, 0.3, and we can even change here, it becomes probability of random variable x equaling to small x, and this can be small x, probability of x equal to 0, 0.1, probability of x equal to 1, 0.6, and probability of x equal to 2, 0.3. If the sum of the probabilities is equal to 1, if the sum of all probabilities from, let's say, from 1 n is equal to 1, in other words, if we sum for all values of x, all the probabilities and we get 1. If we add the probabilities and we get 1, then the variable is said to be random. It would imply that the variable is said to be random. It means we have done our experiment randomly and the total probability gives it all, and therefore the variable is said to be random. Like in this example above, probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 gives 1. That is 0.1 plus 0.6 plus 0.3 gives 1, and therefore x is a discrete random variable. Then in summary, for a discrete random variable, the sum of probabilities should be equal to 1. In summary, for a discrete random variable, the sum of probabilities should be equal to 1 for I ranging from 1, 2, 3, 4 up to the last value. The function that is responsible for allocating these probabilities is known as the probability density function, and the function that is responsible for allocating these probabilities, that is px equal to x, is known as the probability density function of x. We usually denote it as PDF, that is probability density function. We write it as PDF of x. It is a function which is responsible for allocating these probabilities, allocating probabilities to each and every value of the variable. A variable is that thing that changes from one value to another. It is not fixed, and therefore if x is a random variable, then the sum of probabilities for all values of x equals 1. And this is the very important property where the sum of probabilities is equal to 1. That is basically important to be used in mathematics. And we can have an example of how we can use this property to see that we master the property.